Okay, so we are now in example 3.7. In my note, the page is page 12. Alright, so we're going to discuss question number 2 here. Okay, you're asked to evaluate this line integral in a counterclockwise direction from the point 50 along the semicircle to the point -50, and then the second path will be back to the point 50 along the x-axis. Alright, so the figure as shown in the figure, but for this case I want you we're gonna draw it ourselves. Okay, alright, so first of all, from this line integral, data yang we will get from here is the vector. So the vector that you will have the component I adalah y, komponen j adalah negative x. Okay, you tahu ini adalah m dx plus n dy. Alright, so the first thing you need to know. Okay, so secondly, meaning to do the sketching, counterclockwise direction from the point 50. So you have the point 50 along the semicircle path, x square plus y square equals to 25 to the point -50. So counterclockwise, clockwise go this way, so counterclockwise from here to here, from this point 5 to the point of -5 here. Okay, and then back to the point 0 along the x-axis. So the next one is from here to here, daripada -5 kepada 5. So we have two path here. This is your C1 and this is your C2. Alright, so if you notice the first part of the question, find this value, find the line integral or find the work done directly without using Green's theorem. Alright, so it means that you have to use the normal way of finding the line integral, meaning that you cari C1 and then you tambah dengan C2. Okay, so untuk path C1 here, the path is x square tambah y square equals 25. So you know that this is a circle. So bila circle two-dimensional, macam mana you tahu two-dimensional? Because you have x dengan I dengan j sahaja. Okay, so it's two-dimensional. So bear in mind that you will be using double integral. So you will be using polar coordinate sebab tapak bulatan sekarang ni. Alright. Okay, I mention about double integral tadi kan. Okay, double integral maksudnya menggunakan polar coordinate. Polar coordinate, you will have x equals to r cos theta, y equals to r sin theta. That is kalau kita ada double integral. Tapi masalahnya sekarang, bila kita nak solve line integral ni, it is a single integration. So that is why you kena fixkan nilai theta ataupun nilai r. Biasanya kita akan fixkan nilai r. So which means that you punya x akan jadi 5 cos theta, y akan jadi 5 sin theta. So this, you must use this concept bila kita nak buat line integral melibatkan bulatan. Akan fixkan nilai r. Kita bukan integrate menggunakan r cos theta, kita akan integrate menggunakan 5 cos theta sebab circle kita sekarang radius adalah 5. Alright. So bila x adalah 5 cos theta, your dx adalah negative 5 sin theta d theta. Alright, and your dy adalah 5 cos theta d theta. Okay, masukkan semua ini ke dalam kita punya line integral. What you will have, okay, so you akan dapat inilah. So maksudnya y akan jadi ni, this is dx, tolak dengan x dy. Okay, so simplifying this. Sebelum you simplify, you have to see that what is actually your range. Your range ni you tengok it is half of a circle, so it's from 0 to pi. Alright. Okay, proceed with integration. So in the end, you have it equals to negative 25 pi. Alright, so kita tengok kepada C2 pula. C2, our path is the x-axis. The x-axis, you know it is y equals to 0. Maka dy juga adalah equals to 0. Okay, so this is your line integral. Y0, dy pun 0, maka dia adalah kosong dx, tolak dengan x kali kosong. So you'll have your path here, the work done is 0. So C1 Alright, tambah dengan C2. The overall for this one is negative 25 pi plus 0. So in this case, it is negative 25 pi. So this is your result tanpa menggunakan Green's theorem. Okay, kebetulan yang ini dia adalah kosong lah sebab you have the x-axis. Okay, so the second one is you have to using Green's theorem. So you kena mention dalam you punya step using Green's theorem. So this is what you want to search for. This is the formula of the Green's theorem. Okay, so untuk case ni you can see that kita punya bentuk sekarang adalah bulatan. So you have to remember this double integral you have to change it into a polar coordinate. Okay, so your dA ni will become RD theta lah. Okay. Okay, so dn dx. So maksudnya komponen y you derive terhadap x, you can see that you will have negative 1. Okay, tolak dengan komponen x derived terhadap y, you can see that you have 1 here. So 1 here. Negative 1 minus 1. dA ni akan jadi r dr d theta. Theta is half of a circle. So it is 0 until pi. R adalah daripada 0 until 5 lah. Okay. Because it is the radius is 5. Okay. So this is what you have. So proceed with the step. Okay, so proceed with the step. So in the end, using Green's theorem, you have it negative 25 pi. So you can see the same result. So you can just say that it is verified. Verified ataupun you nak cakap shown ke, it doesn't matter. Alright, so what we want to prove now is using the line integral. Okay, you kena mention lah. Using line integral, the normal process. This is question A tadi. Alright, the question A. Okay, so you have to use question A 1 lah directly without using Green's theorem. So you kena mention lah. This is question 1. Okay, and then using Green's theorem ni you kena mention lah. This is part 2. Okay, so you can see that both you will have the same result, which is negative 25 pi. Okay, so this is not a proving question. So no need to say verify ataupun shown lah. Okay, tapi kalau macam soalan nombor 3 ni, you're asked to verify Green's theorem. So after you dah buat dua-dua, you kena tulis lah verified. Okay, so that's about it for the question number 2. Thank you.